today we were told we're going to have a kind of a mixed audience between people that are learning Python, or sorry, that are in the students stage, learning cybersecurity, data science, whatever you guys are learning, but you're in a learning stage. And some other people might be interested in teaching programming in general, not just Python, but programming in general. So I wanted to take the time to show you how we approach the process of teaching. We're going to be showing you a few exercises we have in the platform. And basically, what are those things we have tried that make it more effective for someone to learn programming? Of course, you could just sit and write code, naively, blindly, write as much code as possible. But those are usually, but that's usually time that it's not extremely well spent. With these things that I'm going to show you, we've found that there are some traits that are quickly maximized for someone learning programming, Python, etc. We focus on Python. We're going to see now, because it's basically that glue that we use to get together all the disciplines and all the verticals we have at IMEE. So my name is Santiago. I'm an instructor at IMEE. I focus in data science and programming. And what is IMEE? Basically, we are a company that provide training in several areas, mainly networking, cybersecurity, data science, and cloud computing. Cloud being Azure, Google Cloud, AWS, etc. And as you might imagine, these four different verticals are quite different, right? It's not the same thing to teach networking than it's data science. So those might even be radically different disciplines. So what we have found is that Python is this glue that lets us get all our students in a common space and add this hands-on experience so they can practice as much as possible before jumping to the field. So we offer a starter pass, we call it, which is a completely free option if you want to check it out. It's basically, if you're in cybersecurity, we have a full course, which is penetration testing student. If you're in data science, we have a full data science learning path. This is completely free. It includes practice, lab access. So just go ahead and check it out. I can put this link in our Zoom chat real quick if you want to do it. Sabrina, I just saw your message. Thank you. And let's just go ahead. Why do we use Python? Why do we talk about Python so much? And this is both a combination of what we're saying in the industry and also what we kind of believe it's going to become in the future. Python for us today is this unique tool that is used in so many different areas that it's extremely helpful. And for us, it's kind of the future of computing, programming, etc., because it's the one programming language that you can master, and it can open so many doors for you. There are several good programming languages. So, for example, JavaScript is a very popular language. C# is getting extremely popular lately. We can talk about Ruby. We can talk about Rust. There are so many languages, but Python is the one that today is putting everybody together. It's if you know Python, you will find your way across pretty much anything today, except maybe, of course, front-end development, where JavaScript is the only player along with TypeScript, but those type of languages. So Python is the language that you can use to do a simple script. So you can automate something at your home, because just as a hobby, or it can power the whole machine learning project at your company. So it's this language that is pretty much everywhere. It behaves in the same way everywhere. So if you learn it once, you can then master it for pretty much any other area. And that makes it, in our eyes, extremely unique. So these are just a few examples, but for example, we use in data science, we use Python a lot for the whole data handling, data cleaning. Data handling means like getting the data, changing it. Sometimes you have to pull it from multiple sources. This is usually what takes the most time in a data science project, even though people don't realize, people think that in data science, it's all about artificial intelligence and machine learning. Well, that's not the truth. Sadly, these two items take pretty much the whole time. And Python is great for that. The same thing for cybersecurity. You can automate scripts to, for example, do penetration testing, try to do SQL injection from a Python script. All these things are possible, again, with Python. So what do we want to teach when we get a new student, regardless of their specialty? We don't care if the student is from networking or cybersecurity or data science or cloud. We want to give them an overall idea of what Python is and how to use it, because again, they might be today learning about network engineering, but in 10 years from now, they might be doing cybersecurity or data science. So we want them to have an overall holistic approach at their programming and their decision making, at problem solving with programming. And for that, we focus in the three great virtues of a programmer, which is, it's kind of funny. It's this site that has been along for a long time. Laurie Wall, you might know Laurie Wall. Let me open it up just because it might be people that are not familiar with programming, but basically this person was kind of a counterculture, the style of hippie hacker that created the Perl programming language that was huge, is still huge, but it was huge back in the 90s and 2000s because it was a scripting language. And actually Python is heavily inspired in the simplicity from Perl. It's not so pretty. It's like today, I couldn't recommend learning Perl that much. But again, Laurie Wall is kind of a celebrity in the programming space. And basically these three virtues that he proposes, and they seem pretty funny when you read them, but basically laziness, impatience, and pride are the ones. And basically laziness means when you find yourself doing the same thing over and over and over, and you just say, I can waste so much time. I'm just gonna go and write a script that does this thing for me. Or for example, someone asks you the same question over and over and over again, say, you know what, I will just go ahead and write documentation about it. So, you're not asking me all the time. Impatience means when something is not working, just going and hacking a new solution, just give me 2 days and I will hack you something new and it's going to start working again, or it's going to work. I don't have to wait. It's this impatience of getting something done, of getting something improved. And finally, hubris or pride, which means any programmer wants to do something that is great, right? So you don't want, in any space, if I'm in data science and I do a whole data processing pipeline and we have a new hire replacing me in 1 year from now, I don't want this person to, laugh and say, hey, this is terrible code. I want them to feel proud and say, hey, this is amazing code. This thing works great. It's so simple to maintain. It's so fast. I want them to see those traits about my code, about my architecture. So this hubris, this pride is something we want to keep. Nobody, I think there is a quote here, the quality that makes you write and maintain programs that other people want to say bad things about. And again, it sounds silly or funny, but I think this is a great characteristic of any programmer, being very proud about what they do when they code. So how do we teach Python? What are the main things that we focus on? I'm gonna mute some of you guys. I'll mute you all. There you go. You can unmute yourself if you want. And how do we teach Python? Again, this is you could just sit and start writing code, right? Just start writing code. Try writing a toy project. I don't know. You have an idea. That's great. I mean, as long as you practice, that's great. But we have found a few hacks, a few secrets, if you want, that usually make the learning process more effective. That start shaping the form or like the way your brain thinks about problem solving, that are we think a little bit better than just sitting and hitting the keys with whatever you're doing. And these are the four cornerstones or pillars of our teaching process, teaching and learning, because if you're a student, you will go through these processes. I'm gonna okay. So the first one is pattern recognition. Pattern recognition means understanding that programming is all about patterns, right? It's something has to get in, something has to get out. If you are coding, for example, a simple script that when the sun comes out every morning, it will pull up your curtain with that simplicity up to, for example, a Tesla self-driving car, everything is about patterns. Patterns in the way you're detecting when the sun comes up. So you have a signal there, you need to detect it somehow. And when that happens, you will need to trigger some process and do something after that. The same thing happens again with a very complex system. With a self-driving car, it's the same thing. You are detecting something with a signal, you are activating a function, it's a black box, and there's going to be an output out. For example, what to do with the car, where to steer it, etc. Thank you. And then problem solving. Problem solving is basically understanding that things will go wrong and it's impossible to make perfect code. It's impossible to predict all the outcomes of something. It's impossible to test every scenario. We do test-driven development all the time in our courses. And when we ask our students, do you think that you have tested pretty much every scenario? So let's say you're writing a function that, for example, captures an email address and gives you the domain. And it tells you this email address is from Gmail or Microsoft, or it's a private one. How many tests do you have to do to make sure that thing works? Well, the reality is that you have to make infinite tests because there are an infinite number of possibilities of different email addresses. Of course, we are not making an infinite number of tests. So at some point, you might test it very well. You might do like 10 tests, 15 tests, and you might be very confident that that thing's going to work. But eventually, everything breaks. Eventually, in production, something will go wrong. Some will break. So understanding what went wrong, where, how can I mitigate the issues and all that? That's the important part. Then self-sufficiency means being able to move fast, being able to solve problems by yourself. And these are, of course, two very related, but from, for example, trying to answer your own questions, trying to look up for documentation. As programmers, we use, for example, Stack Overflow all the time. You might probably have heard about that. We use Stack Overflow all the time. But from a Stack Overflow question, there might be several answers that are there and they all seem valid. So how can you judge when one of them works or not? this is self-sufficiency, being able to make clear decisions, to understand what are the consequences about them, which is fine. Sometimes you might understand that this thing will have potentially that issue, and you still go ahead and do it. You document it saying, I understand we might have this problem now, but we need to move fast, so I'm going to do this. And finally, what pretty much puts everything together is working practically. I have been this is kind of obvious for me, but being practical, writing code is what you need. And my analogy here is, if you want to be a good football player, you don't sit and watch football all day. That will not make you a good football player. So you can watch as many Python programming videos as you want, but that will not make you a good programmer. To be a good programmer, you have to go to the field and play. You have to go to the field and start coding, write your own projects, etc. So let's break these three down. There's someone that it's unmuted. There we go. I'm gonna go ahead and start giving you a few examples that we deal with in our platform, that it's also part of the starter pass about this. So for example, pattern recognition. We have these programs that we usually practice in our introduction to Python course, in which we ask the student to write the code for a function, and we're not giving them any background, any explanation. Most of the programs that we ask our students to do, for example, I don't know, let's find something here, greater than 20. Write a function that receives a number. If the number is greater than 20, return true. That's it. Very simple. In this case, we're explaining to the student what we want. We're giving the student explanations. This is the common case. But there are some other exercises like these ones, guess the pattern, in which we're not giving the student any hint about what needs to happen or how this function needs to do. The only thing we give our students are the test cases and how the function reacts to several examples. This is a good example of black box. We give you the input, we give you the output. You have to figure out, you have to guess what's going on internally. And of course, you have to write the code in whatever way you think it's best, right? So in this case, the function receives the number 2 and returns 4, receives the number 3 and returns 6, receives the number 5 and returns 10. Does anybody know what this function is doing? Like, do you see the pattern? Yes, multiplying by 2, yes. It's doubling the input and returning the double of the input, right? So in this case, we could do return x times 2, for example, or someone else could just do x plus x, right? We don't know. And importantly, if I try submitting this solution, we don't know and we don't care, right? So this is correct. I don't care if you do x times 2 or x plus x. I don't care as long as the function behaves as expected. And again, it's kind of challenging because we're not telling you how the function works. So for example, this one receives 9 and returns 4.5, receives 10 and returns 5. Do you see the pattern, anybody?
Dividing by 2.
Yep, dividing by 2. So again, it's x, return x divided by 2. And if there is anybody, maybe you joined late, but the objective of this talk is to make it both for learners. So if you're learning Python, but also if you're teaching Python and programming in general, this is one of the crucial things we have done with our training, which is giving students complete freedom to investigate how something should work, just giving them the hints. What should go in, what goes in, what goes out. You have to figure out this in the middle. And this we do this even in machine learning projects. So in this case, it was just multiplying by 2, very simple. But when you get into a machine learning project in which we give you a huge data set with maybe 1,000 rows and a lot of columns, and then we ask you, we show you outputs that we're generating, and you have to figure out what's going on. That takes a lot of brain power, you know, and it's these great traits that any programmer, machine learning specialist, cybersecurity specialist can have, which is guessing and understanding patterns. So let me see if there is any other interesting example here. This is negating multiplying by -1 with multiple arguments. So in this case, do you see what's going on, anybody? Oh, Duran, I didn't see your question. How do you run test your function.py? So we do this in the background, but basically this, if you're learning Python, this is very common. This is, yes, yeah, this is multiplication. This is test-driven development, which is basically on one side, you write the signature of the function that you're going to be writing. So in this case, I know that this function will receive 2 parameters, and that's it. You leave it empty. You even put a pass statement, so you leave it empty. And in some other place, to put it in a way, you write your tests so you can make sure that your function works as expected. So you write all your tests even with an empty function. That's actually expected. I mean, you know what the output of the function should be, right? So if even, again, from a simple example to a more complicated example, you do it all. So basically, in this case, you write the function, you put it in a single module in a .py file, and what we use is PyTest. And the function here doesn't need to be in the same file. Actually, it should probably not be in the same file, but it should be importable. So at the top here, which is not shown because, again, we do this all automatically in the platform, you will do import my function somehow, you know, from my module, import my function, and you will import the function so it can run. But PyTest, it's pretty much here is a command that will run the tests. Okay, so second big thing that we try to do is, again, problem solving, like put the student in a tough situation, even if it's too early. Like for example, this is the first course in our Python career. It's extremely basic. We talk about variables, we talk about data types. And just at the beginning, we start, you know, like here, you probably went 2 hours of Python learning tops, 2 hours. So right in the first 2 hours of your learning, we will ask you to start thinking about test-driven development and about all these use cases and all these scenarios. And, you know, it might seem tough. Like if you look at other courses around, you will see that they don't get to testing. They try to do the simple things, you know, write a calculator in Python. We like to get into the most complicated part first because we think that this is the best way to train your brain to think as a programming. And one of them is put you in an awkward situation, put you in a tough spot. Like, for example, in these type of exercises. So this program is broken. This program is broken. We are giving you a broken scenario, and you have to figure out what's going on here. So if I just try submitting this thing, this is broken. Again, it's going to blow up. There you go. Broke. Something is not going right. So we are putting you in this tough situation when you have to learn how to read errors, how to, you know, find issues in stack traces. And this should not scare you out. usually when a new student sees these messages, they freak out. They hate them because, you know, it's failure. It's nobody wants to have failure, you know, right at the front of their faces. So we want to make you feel comfortable with errors because it's something that is going to happen all the time. We want you to make you read programs all the time. So, so for example, Jaya is proposing a solution that it's basically making these things an integer in both of them. This will not work. It's still a smart solution. We will try it. This will not work. We can try it again. And now there's going to be another error. So this is interesting. We did something and now there is another error. So here the key is, again, getting comfortable with the error messages. We're getting closer, understanding what's going in and what's going out, what should be in, what should be out. And basically we see here that this add function, it could potentially be executed with a character and an invalid number in this case. And in that case, this should be returned none. If the function is submitted with the correct parameters, that means numbers, the output is just should be the sum of those numbers. So here we can get a little bit more, you know, intricate. We could do something like if the type of A is, for example, different than int, and the type of B is different than an int, then return none. We could do something like that. In other case, just return the numbers A plus B. And there are several solutions. I could try them all just to give you an idea. Again, what we try to do here is type of A. Well, I did something wrong. Or it should be or. What we try to do here is basically, we don't care how you solve the problem, as long as it's solved. You will have countless opportunities to revisit your solutions, to refactor your code. So for example, here, the simple question could be, what happens if someone submits a number that it's not an integer, right? So for example, 3. This is still a perfectly valid solution or execution of this function, adding a float and an integer. But in this case, my code will not work because my code is explicitly expecting integers. So here we could say something like, we could start getting it a little bit more complicated. If the type of A is different than int and the type of A is different than float, for example, right? Or decimals. So we could keep improving the function. You could even refactor all the way around to if the type of A is a string or the type of B is a string, then return none. So again, you can look at the same problem from different edges. We don't care, as long as you can recognize the pattern and you can fix the problems that we're giving. Any questions about these type of problems? There are plenty of these. We have them pretty much everywhere. Every course will have a few, you know, examples of exercises that are just broken, and your objective is to fix them and understand why it's broken. So the third point that was, again, self-sufficiency. This is a little bit more challenging. This is usually in our projects, but we will ask you things like, for example, just how can you get the bits, you know, bit representation of a Python integer? And that's it. We will not teach you this. There will be no video that is basically, this is how you get bits from a Python integer. We will just ask you, and you should go ahead and Google it, right? And then we have a video in which we are Googling it, and we explain you what's the process we follow? Like, for example, if I go, how to get bits from Python integer, right? And I will get into Stack Overflow answer, and I will start seeing different options. And then I'm going to ask, what is this thing? And that thought process that we follow as experienced programmers, that's what we want to give you, right? And the same thing with Google looking up for documentation. There are some questions that are, go to the documentation and find the difference between these two functions. And it's just that. That's the exercise. You have to go look the documentation, read it, and don't be scared by the documentation either. And this is, again, a little bit more challenging to do, but we want to explain you that programming is not just sitting and writing code all the time. It's reading, it's finding, all answers and interacting with pretty much the whole universe of options that you have. And then there is this last point, which as an analogy, I like to say that we first want to teach you how to use and how to master each individual tool. And then we're going to ask you to build a chair. So this analogy with carpenters, for example, is all these programming exercises that you're doing right here, all these programming exercises will teach you one individual, or will help you master one individual tool. In this case, we're talking about functions. So all these exercises are about functions. We can go ahead and, for example, if statement. We have a bunch of exercises all about if statements. We want you to be very comfortable with if statements. Same thing for, I don't know, nested functions. 2 exercises about nested functions. So all these exercises, individual exercises, are helping you master that given tool. An if statement, a function, a for loop, a nested function, all these individual tools. But then after you have mastered some of these, we can actually go to a different course here. Go to, actually we have here, I have an example. I will open it up. Give me, I think this is important for you to see. I'm gonna open the Pandas course. We have this one. I'm going to show you one of the projects we have. Well, I don't know what's going on with my connection. So this is an example of a project that we have. And this project, what we do is we give you a big data set of sales of bikes. It's a pretty common data set around the internet. Basically has a bunch of sales from a bike store, and we will ask you to do some analysis, and we will ask you a few questions and to do some reporting and some visualizations. And in these type of projects, the individual tools, how to use an if statement, how to use a function. In this course, we also show you, for example, how to create a pie chart or a bar chart, or I don't know, how to get the mean or the average of a given variable. We teach you all those individual tools, and then we put you in a test, which is basically, now you have to combine all the individual tools towards a given goal, which is building something. It's building that chair. When we put you in this situation to finally complete, let's say, a useful project, in that case, you have to understand what tools to use, because maybe we taught you several tools, but for the chair, you don't need all of them. You need to just focus on a few ones. So understanding which tools you have to use, at what situations, for how long, and sometimes there are differences, and here's a project probably. Sometimes there are like the same tool, or sorry, the same problem can be fixed with several tools. So for example, if I ask you, let us visualize the best, I don't know, the best week of sales. or the best 5 weeks of sale. You can maybe do a bar chart, or maybe you can do a line chart, or maybe you can just give me a table. Week 1, this many sales. Week 2, 2% below. So there are several ways that you can fix, or you can basically achieve your goal, whatever we're asking you. I want to visualize the best 5 weeks of sales, and you can tell me it was, week 4, 2019, week 3, 2020, week, I don't know, 30, 2018. And again, it can be a bar chart, it can be a list, it can be a line chart. There are several tools you can use in order to do that. So that's what we try to focus on, is giving you a very high level project in which you have to make decisions. And again, we don't care how you achieve that. Sometimes there is a better solution than the other, but as long as I understand, if I ask you the best 5 weeks of sales, as long as I can see which ones are those weeks and maybe get a pattern from that, I don't care how you do it. So this is our fourth pillar, which is giving you practice in which you have to find what's the best solution for that, what's the best tool to use, when to use it, and when not to use it. Because again, in this course, we're teaching you a bunch of visualizations. We're teaching you from, all the different type of charts, different tools to do charts like Matplotlib, Seaborn. And the project doesn't ask for everything. The project asks for specific things, and you will need to pull those solutions from your toolbox. So this is pretty much the whole presentation that I wanted to give you. Again, this is aiming for both learners and teachers of programming. If you can carry like a summary, these 3 things, these 3 great virtues that we want to get from a developer, and the way we try to extract those virtues is by following these 4 rules: pattern recognition, problem solving, self-sufficiency, and again, a ton of practice. So these are our pillars. Finally, 2 things. There is a completely free option IMEE, which is called the Starter Pass. I think all the exercises we've seen, except for this project, are part of the Starter Pass. So go ahead and sign up if you want. And if you're going to go premium, again, we have cybersecurity, data science, networking, several verticals. There's a coupon code with discount, which is HACK499. I will send the link over here if you want to use it. Any questions, any comments about all these? I'm more than happy to answer them or give you more details. I was muted. So the course, you can join it with this one right here, or the coupon code. So I'm going to put both links in there to join. There are several courses. That's the reality. There are several also included in the Starter Path. So for example, in data science, we have an entire learning path for the Starter Path, which is this one right here. In cybersecurity, the Starter Path includes, for example, penetration testing student, which is a great course. It includes hands-on labs. So you will be practicing, penetration testing with a real project and real computer. So this is pretty neat. All right, thank you everybody for joining. Again, if you have other questions, I think Johnson can forward them. There will be a recording. Duran, yes, the penetration testing student, I am 90% sure you can get the EJPT is called the certification. That is very useful in the industry. Let me give you the URL of the certification, and I can double check the penetration testing student, the certification associated. But this is the entry point, you know, the entry level in the cybersecurity community is, or the industry is, getting penetration testing student and then getting this first certification. And from there, you know, everything follows. Saludos, Ana.
Un beso a todos en español.
Gracias. So there is the elearnsecurity.com site has all the certifications. We don't certify at IMEE. We do provide all the training. I think again, for PTS, penetration testing student, the certification is EJPT. You're welcome. All right, folks, great to meet you again. I know you have a Slack channel. If you have any questions, put them there. Jensen can probably forward them to me, and we will post a recording soon. Have a great day.